I'm going to just pull your first video through. Let's do that.
Okay, well, today we're going to be talking about the nutritional deficiencies of the elements, minerals, the elements.
Trace elements, that's lovely.
So we're going to get to the trace minerals after in a few minutes, but first we'll do the major minerals, the elements, the key elements.
So do you want me to play?
Start. Go ahead.
You want me to start? You want me to start the video? Okay.
Now we're discussing all the different elements and the atoms needed by biology. Mendeleev, way back in 1869, the Russian who developed the periodic table, did all of his work based on observation of elements. Predicted elements weren't even discovered. Now today we have the periodic table of the elements. Here in green we have the key elements of biology, not really minerals. Hydrogen, oxygen, carbon, nitrogen. These are the key atoms that allow a life. Now there's a master equation of how plants, using carbon dioxide, water, light, chlorophyll, will make carbohydrates and then oxygen. That's what the plants do. Now, then in reverse, animals will take in the oxygen, take in the carbohydrates, and give off carbon dioxide and water. This whole cycle that's then dependent on oxygen, water, carbon, nitrogen. This whole cycle, the master equation of life, and the whole process uses quantic, subatomic, quantic operations to happen. And in the world, there's the carbon, oxygen, nitrogen cycle. The cycles of the reoccurring reabsorption, release of oxygen, carbon dioxide, nitrogen. And this is all responsible for the pathway of life. And our first real understanding of the periodic table is to understand how oxygen with nitrogen, carbon dioxide, oxygen, water, all work in harmony, allowing for biology. It's very important that we as humans get a source of our air with the oxygen and the nitrogen and carbon dioxide, and also get a source of water, our two greatest nutritional deficiencies, water and air. So what we just learned is that air is very needed. We need the carbon dioxide, the oxygen. Air is our major nutrient, water, our second nutrient. And this is all in a cycle, and it depends on plants that can take in the carbon dioxide, take in the water, take in minerals, for them to be able to process and make carbohydrates and oxygen. We take in the oxygen, we take in the carbohydrates, and the great big cycle of plants and animals continues. This is all done in a magic way that none of the chemical companies, no chemist in the world has any clue of the complexity. The natural process of this whole cycle is so vastly complex, it's probably more complex than we could even imagine. We must respect it, we must be humble, and we must recognize that if any type of medicine we do, we're going to have to really get down to respect the plants, their part in this, and respect the oxygen, the air, respect the water. And this is very crucial. So we started our idea of the elements by dealing with these first group of elements, which are the basic constituents of life. Okay? Now the next video.
Absolutely.
Going into the next step. The next video is going into the next step, because in order for this process to work of carbon dioxide, oxygen, all of this process, all of this cycle, it now will take the other minerals, and these other minerals will be needed. And there's a magic here, and I made this video. I think you'll like this one. This is on alchemy.
Ooh, lovely. Thanks, Desi.
Modern science starts with an incredible man
who invented a new branch of math called calculus, figured out the composition of light, and gave us the laws of gravity and motion which govern the universe. The man who is considered the founder of modern science, Sir Isaac Newton.
Newton's work has a beauty and a simplicity and an elegance that makes it the greatest work of science ever done.
This incredible scientific mind looked into gravity, light, perspective, the ideas of religion. He also looked into the science of the elements.
Newton was elected a member of the Royal Society, a group of leading scientists in London. Most of them were awed by the whiz kid from Cambridge, and Newton was so delighted that he promised to send the Royal Society a paper he had written on his discovery that white light is made up of different colors.
Newton's keen mind was also expansive as he started to look at the ideas of life and what was happening in this blend of items of the universe, time itself.
His private notebooks reveal that the same year he became a professor at Cambridge, he bought 2 furnaces, an assortment of chemicals, and a strange set of books. Isaac Newton had become an alchemist.
Alchemy is the exciting study of the transmutation of matter, energy, and time. An exciting concept, an expansive concept. I welcome you to The Alchemist.
Alchemy is an ancient and secret practice with roots in the Middle East. By carrying out lengthy and complex chemical procedures, alchemists tried to produce a magical substance called the Philosopher's Stone.
The search for the Philosopher's Stone. There were many famous alchemists. The list is way too long. Here's just a short list. People trying to find out some of the secrets of the universe and the secrets of life.
One of Newton's recipes, called the net, comes from the writings of the Roman poet Ovid. In his poem, The Metamorphosis, Ovid tells the story of the god Vulcan catching his wife, Venus, in bed with the god Mars. According to the myth, Vulcan made a fine metallic net and hung the lovers from the ceiling for all to see. In alchemy, Venus, Mars, and Vulcan mean copper, iron, and fire. Viewed this way, the myth becomes an alchemical recipe. And if Bill Newman has interpreted the recipe correctly, he should get the same results that Newton got 300 years ago. A purple alloy known as the net, which was believed to be one step towards the Philosopher's Stone.
Many have sought the Philosopher's Stone, the concept of alchemy, inside the laboratory. But what if this was actually inside biology, inside the cells of all of us?
Historians have also discovered that Newton was not alone in pursuing alchemy. Other scientists of the day, including members of the Royal Society, were alchemists too. Perhaps Newton's alchemy was less an occult practice than another way to investigate the natural world.
Carl Jung could see alchemy.
I was always looking for something in between, you know, something that linked that remote past with the present moment. And I found, to my amazement, it is alchemy.
Carl Jung found that alchemy could be the link of the human brain to understand time. Not just matter and energy, but time.
Alchemy was really matter theory. Alchemy was a science which pursued the most basic questions of what is the Earth, what is all of the universe made up of? What are the components of matter?
It was a profound element to the practice of alchemy, which really makes it deserving of being called early modern chemistry.
Basis of our modern way of conceiving things. And therefore, it is as if it were right under the threshold of consciousness. This is a wonderful picture of how the development of archetypes, that means the movement of archetypes, looks when you look upon them as if from above, maybe from today you look back into the past and you see how the present moment has evolved out of the past.
He's not a madman playing around with strange spirituous substances. He's trying to actually figure out how to change material particles around to get one thing out of something else, and that's not so weird.
Alchemy is an expansion of mind to understand the transformation and transmutation of the elements and the potentials of the human spirit and the human mind, because those potentials are infinite.
And we can construct or even predict our the unconscious of our days when we know what it has been yesterday.
Carl Jung saw alchemy and dreams as the transmutation window for us to see into the future. Here is the rebus. This is an ancient symbol of alchemy. It's a symbol of a hermaphrodite, male and female, where these opposing forces of male and female need to be unified by transformation, transmutation to maximize the potential of the human brain, the human mind. Now, getting back to elements, we saw that Rutherford showed us how the items can be transmutated. Kervran developed the idea that there was a transmutation inside biology, and he wrote many books on it. We started working on this as well. Here at Youngstown State University, way back in the 70s and 80s, I joined forces with the Nobel Prize winner, William Fowler. We co-authored a paper on the transmutation of the elements. And as we started to see this, we started to analyze the different elements and realize that transformation was possible and that alchemy was possible. What Dr. Fowler and I had found is that with slow nucleus capture of the neutron, and then with that neutron decaying, beta minus decay, that neutron could be converted to a proton, and then potassium could be converted to calcium. Amazing. We had already seen this in science with magnesium to sodium, and that this ability of the beta decay of a neutron into a proton, this has happened, this was basically found, and it had happened in many other type of elements that have been known to science. So this was indeed a real thing. This has been seen in the laboratory with radioactive materials, but could it be that we have now found that and proven alchemy, and that we have been able to show without a doubt it was possible that we found the Philosopher's Stone. And the Philosopher's Stone we found inside biology. And we've proven that alchemy inside biology was possible. But what about the whole idea of gold? Well, our idea of the slow neutron capture would apply if we wanted to convert platinum to gold. But wait a minute, platinum's more expensive than gold. We could not find any other way. So the idea of converting into gold, that has eluded us. So we were able to kind of give up on that precept. But back to biology, the basic concept of breatharians, being able to live just on breath, taking in the carbon, the oxygen, the nitrogen. Life could only be possible if there was a transmutation of the elements. So to understand biology, we must understand breatharians. They do exist, documented in all the major religions. And only through transmutation would that be possible. But we see that this is through the religions. So you have to have a spiritualness in order to be a breatharian. Autophagy might be able to explain part of the idea of the breatharian, being able to recycle their own cells. But in order to really understand, we'd have to be able to show nitrogen conversion, we'd have to absorption and conversion, we'd have to show the sunshine, and we'd have to show the transmutation of the elements. And normally people make fun of breatharians. They take one breatharian and make fun of them, but you see, it only takes one white crow to prove that white crows exist. Just one breatharian. And I think there's a lot more than one. So we need to be able to look at breatharians with a little bit more of an open mind, more of a Buddhist mind, and then understand.
Now we will see more of the powers of the mind when we turn off the verbal parts, going into the Buddhist philosophy.
That people draw great pride and inspiration from here.
Rambonjan, a 15-year-old boy, has been meditating in dense jungle without food or water for 10 months. Many suggest he is a physiological and cognitive freak, with such immense power of mind over matter that it could change the way we look at modern science and medicine forever.
If he's truly gone without food and water, it's difficult to explain on a purely scientific basis, so you'd have to bring in spirituality in here.
The longest a person can go without food has been documented as being around 2.5 months before you die of starvation. In an open environment, breathing normally with warm air surrounding you without any fluid at all, you would last between 4, perhaps 5 days.
Rambonjan has not eaten and, more importantly, not drunk anything for 10 months.
I studied similar cases in the past, and this is possible.
Through his deep meditation, he's gone into a hibernating state, and he is living on spiritual energy.
I can't accept that. It goes against what I know about how the body works, about the nutrition that you need. He's getting food and he's getting fluid from somewhere.
He is surviving on nourishment. The question is, what kind of nourishment? We can't, as Westerners, tap into using spiritual force and spiritual energy for nourishment. That's the key here.
To endure solitary existence in extreme conditions, yogic techniques enable you to focus your mind over your body's suffering.
Obviously, if he's genuine, has to use some yogic techniques like feeding on the air, feeding on the breath.
Fascinated to see the boy who is fasting for 6 to 8 months, and that is not at all really so exciting to me, because I studied similar cases in the past and I can understand this is possible.
Dr. Shah's most famous case is Prahlad Jani, a holy man who claims he has not eaten or drunk anything since he was 12.
I haven't eaten anything, not even now, even though I'm 80 years old.
That made me really quite excited, because I knew that this is something going to change the feeling of medical world.
Although I walk 100, 200 kilometers in the jungle, I never sweat, nor feel tired or sleepy. I can meditate for 3, 8 or 12 hours or even months.
Prahlad Jani recently spent 10 days in observation, watched and filmed 24 hours a day.
So here we see basically some type of a proof of that breatharians do exist, and that they do have an ability beyond the ability to get nutrition, sunshine, take nitrogen out of the air, transmutate the elements. And now we have to think of a new idea regarding deficiencies of nutrients, about the spirituality. Not just getting nutrients, but being able to take those nutrients, those minerals, and transmutate them, having the spirituality. And now what we've done, we've basically found the Philosopher's Stone. the principles of alchemy and showed that they really have a reality. We have to expand our mind. Here's an excerpt taken from Isaac Newton's book on alchemy. So, inside biology, we found the philosopher's stone of alchemy. And it broadens our mind into looking into other different things, into the mind itself. And our good friend Carl Jung was right. Alchemy is a psychological process. A psychological process that can affect physiology. Yeah, so William Fowler won the Nobel Prize for discovering how the sun, or how a star, converts hydrogen and helium into all the elements. All the elements are born in the stars. That's how all the elements are existing. So he won the Nobel Prize for describing the mathematical process, how it worked. Very interesting. And so then he was from Youngstown. He won the Nobel Prize, and he came back to Youngstown State University to lecture. And I was in the room, and I asked him, I said, could it be possible that inside biology that we could transmutate the elements? Because there was a Frenchman, Louis Kervran, who had shown this. And he looked at me and he said, no, that's impossible. He said, if we took potassium and let it capture a neutron, and then the neutron had beta decay. And then he turned to me and he said, wait a minute. He said, I think it is possible. Because if you're a fruitarian, you're going to take in massive quantities of potassium, but you're not going to take in much of calcium. So how would certain people be able to make the calcium that they need for bones? Calcium in the human body, calcium is 50 times more plentiful than potassium. So how would we get that? Well, could it be that under good spiritual training, that the body would be able to make that calcium, transmutate the elements? And this is something that modern medicine just doesn't want to accept. Modern medicine doesn't, because it implies some type of a degree of spirituality. We don't find this happening in the Hells Angels people. We don't find breatharians in Hells Angels. We find beer-arians, but not breatharians. So I thought, so we put this together, and even though I published that article a good 35 years ago, and still modern medicine just can't get a handle on it. So I have one more video to show us now to talk about the trace minerals.
All right.
That one. Make sure you start at the beginning. Let's study minerals.
Don't feel right? Minerals are missing. Now, minerals are more important than vitamins. Vitamins are required for activity and processes in the body, but each vitamin requires a mineral to work because every vitamin has a mineral center. Now,
Mendeleev discovered the periodic table because he saw by observation the effect that these different elements / minerals had. And we have to recognize that these minerals have effects on life and biology and are needed for health.
And minerals are energetic compounds that support life processes. So they act like mortar and bricks of our body. All body processes are dependent on minerals. And there are two classes of minerals. There's big minerals and little minerals.
So all these elements, all these minerals get together to make what we are, to make biology. And each one of them has a little tricky place where they fit in. Some don't fit in at all, but others are essential. And basically, we start to understand that through the same process that allowed us to understand how matter is formed in the stars. We can start to see what is the effect of minerals on health and where they are needed.
When you're not getting enough minerals, you get sick. It's said that 80% of health conditions can be traced back to a mineral deficiency.
That's right, Dr. West. We need these minerals in order to help the facilities of metabolism, reproduction. These little minerals are key, as they all have little spots. They all have little bits of helping electron transport chains, and here at the electron poisoning curve, and they all have their different effects. Ravishi saw this as he started to look at it. And if we look at the size or the weight, if a ping pong ball is hydrogen, we see iodine is like a basketball, and the heaviest material weighs like a bocce ball, 800 grams. Now, we've already covered the essential nutrients of oxygen, water, carbon, nitrogen. These are the base elements, and we saw that they make up 99% of the human body. And now what we're going to do is look at other elements. We're going to look at the macro elements and the micro elements and try to understand all the elements in biology.
Minerals are overlooked. It's the missing piece in healthcare. If you don't feel right, it's almost always a mineral deficiency.
Yes, minerals are extremely important. And Dr. Ravishi taught us the law of dualism. We get the same kind of symptoms from a deficiency of a nutrient as if we get an excess. So it isn't always just taking the minerals, it's learning how to adjust and get the right amount. And nature most of the time has the answer. So now let's start to look at the next level. Let's look at some of the macro minerals. And let's start to understand what they are in the body. Because now we're going to be looking at calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium. These elements play into the master equation of life and to understand how that things are regulated. And as we look at them, we're going to see that the mineral content of the macromolecules makes up most of us. These are minerals known as inorganic minerals that build cells, stimulate chemical reactions, nerve impulses, and also allow oxygen to do its job, and carbon dioxide to be transported away. Food is where we should get these minerals. We know that we really should be getting these minerals from our foods. That's the best way. The essential nutrients, minerals, vitamins, fatty acids, amino acids, to get into the body. And there are macro ones, like we talked about, and trace ones. We're going to cover the trace ones in a few minutes, but let's talk about the macro. Potassium. It helps with the nerves, muscle control. Banana and prune, carrot, that's where we get it. That's how we get the potassium. We'll talk about that more in a minute. Chlorine, also very needed for the stomach acid. We get it from table salt, but also from all the other different vegetables. Sodium, another macro unit, helps for the electrolytes and nerve impulses. There again, table salt, but also from all the other impulses. Now, as we look at potassium and calcium, the big balance, we're going to see what we've taught you before about the energy index. Take the blood pressure, the high and the low, okay, and then add them together, and then times it by the pulse. And what we're going to now get is the idea that will tell us the amount. If we get too high of a number, that means that we are potassium deficient. The sympathetic nerves are needed. Too low a number means we're calcium deficient. So you should learn all this based on our course that we teach you about the energy index and the blood pressure. Now, in order to understand this medically, if we take the serum potassium, but potassium likes to go intracellular. So in order to understand potassium best, we need to take the whole blood potassium and the serum, as you see here in the graph, and now we can find out if the person is really potassium deficient, fatty acid deficient, or sterol deficient. And we start to understand more about potassium. The human body needs a whopping 4.7 grams of potassium a day. This is a massive amount. It's hard to get that from foods. But this is what we need. Now, we also should understand that the body can take potassium and make calcium if you have a spiritual purity. We talked about this in the Breatharians book, and we tried to understand more about the alchemy, that how a spiritual human body can convert those minerals. Potassium deficiency is rampant, and people need to get more foods. They also need to work on their spirituality so that their body can be more stable. Calcium is by far the greatest macro mineral needed for muscle, bone, digestive system, and we're going to get it from dairy, but also from green leafy vegetables. That's the best place. Phosphorus is another macro mineral that's extremely needed, and in order for us to get complete phosphorus, we're going to need to be able to get the dairy foods, meat, and the phosphorus is needed for the bones. It also is essential for the working of DNA, the conversion of the energy molecule, ATP, and all of this thing. And we need to understand that most people are not deficient in phosphorus. It's in so many different foods. So very, very rare do we find phosphorus deficiency. But then magnesium now. Magnesium is a very key mineral that's needed for the production of energy, needed for adrenal function. It's extremely well needed. And spinach, legumes, nuts, seeds, whole grains, these are very, very important that we get the amount of magnesium in the body. And sometimes we need to take extra. Stones will form in the body when we're magnesium deficient. That's one of the ways we can tell a magnesium deficiency. Now we're going to move on and look at the more micro minerals. Iron will head up the list because it's needed for our blood. It's needed for the hemoglobin. Proteins, enzymes, we get that from meat and seeds. Zinc, extremely well needed. Does so many things. Enzymes. We need to really make sure we're getting enough zinc. Manganese, cofactor in many, many different enzymes. We need to make sure that we get plenty of manganese into our diet. Copper, extremely well needed for different enzyme functions, etc. Iodine, needed for the thyroid to work properly. In very, very small amounts, but it's very, very huge atom. But we need this to help regulate things. Chromium, needed for glucose and lipid metabolism. It's very, very important, and chromium will tend to make foods be dark. Molybdenum, this is also needed for enzymes, and we get it from legumes and nuts. Selenium, very needed, trace mineral for antioxidant enzymes. We get this from Brazil nuts, very, very important. Cobalt is another very needed mineral that we need to synthesize the B12 for us to be able to regulate our energy transmutation. The use of petrochemicals, pesticides, insecticides, these synthetic products around the world have so robbed the microflora in the soil and created problems so that the soil is depleted of the different minerals. The bad farming techniques without rotation, etc., have contributed to a major loss of nutrition and especially minerals, trace minerals, in the soil. These are the foods that are richest in those minerals, but we have to be careful to try to get foods that have been grown by good organic farmers who really care about mineral recycling. And of course, seaweed, different types of algae, very, very important to get some different seaweed into your body because they will have a greater likelihood of keeping all of the different trace minerals. Put seaweed, algae, salads into your diet. If you want supplementation, there are many good full mineral supplements, including the humic and the fulvic acid variety, and a host of other different types of formulas. And I regret to say this, but I think that we all need to be able to take some type of mineral supplement. Now let's look at each of the minerals individually and see so that we understand them. Sulfur, very key element in our table that we need. We need to get onions and garlic to make sure we get that sulfide type compounds. And many people don't get enough of this and they're sulfur deficient. They don't like the taste of the onions and the peppers. So they get fatigue, depression, degenerative disease. They get sensitivity to physiological and psychological fitness. Other foods rich in sulfur are the cruciferous vegetables, red meat, allium, the onions, garlic, eggs, walnuts, dairy products, fruits. Very, very important. We need to get the sulfur into our diet so that we can get healthy. Many people get deficient in the sulfur compounds. A good onion garlic soup can help that. Zinc deficiency. So many people are zinc deficient. Our soils are becoming deficient in nutrients, especially zinc. So we really need zinc to work and control the immune system, the reproductive system. So it's a very, very important micronutrient that is needed by the body. It has so many different functions, it's hard to even talk about all the functions that zinc does. Lithium. Lithium is a very important needed formula to help stabilize the nerves. And we find it's very rich in chamomile tea. 7-Up used to be a lithium drink, so we need to be able to recognize that. Pistachios have lithium. Boron, very, very important formula, important element that helps to control the immune system, helps to prevent and fight arthritis. Very, very rich in pistachios. Molybdenum, needed for the thyroid function. Very important. Molybdenum is needed, and we have to avoid overtaking it so that we don't get toxic. So it's very important. Manganese. The richest food in manganese is black pepper. Manganese is needed for so many things, including cartilage formation. Black pepper is the richest food. Just by seasoning, you can start to get manganese. Vanadium, tin, silicon, nickel. These are all also other essential nutrients for life. And the vanadium has been found to be helpful in healing and also helpful in liver treatment. So we have to understand that these things are all compounds that we should get from good food that has been prepared properly. Copper, very important, helps the cognitive compounds and helps so many different things, different nutrients. With the depletion of the soils, we need to get good quality soils, good quality farming techniques that are helping to make sure all the minerals are properly there. Selenium is the least abundant of the trace elements, and it's very, very important in treating many things. Chromium for blood sugar regulation, very important that we get all of these minerals. In order to get these minerals right, we need to be able to have a well-balanced, healthy diet, organic farming, people who really take farming seriously, not just for volume. Farmers who care about quality, not just quantity. Cobalt, extremely needed, etc. Fluorine is a nutrient, but in very, very small amounts it helps in teeth. We now even know that bromine is an essential nutrient for life. And what we know is we start to find out that there are certain of these nutrients that are needed to make transistors to help electrical flow. Germanium is one of them. So it's very important we get a touch of silicon, and we get a little bit of arsenic as well. And arsenic has been very helpful in treating leukemia. A tiny bit of arsenic is helpful. That could be also the hormetic effect. So let's talk about some of the hormetic compounds that we see here in red. A small dose of something in a hormetic can have stimulation effects. What a poison does in its large dose, a small amount will have the reverse effect. Strontium is needed for the bone in a very, very small amount and can be classified as a hormetic. So we have to recognize that these are elements that in small doses are stimulants, but in large doses they're poisonous. Antimony, another example of a hormetic element. And as we see that lead, cadmium, mercury, these also can have hormetic effects. In very, very small doses, they can be stimulants. Then we see that silver, and we find that gold. These are also compounds that have hormetic effects. It can stimulate the immune system. So as we look at more and more of this, we start to see that here, under the ideas of negentropy, quantum biology, all of these elements are very, very important, and we need to get them from good, proper foods, organic foods, by a farmer who really cares. So the lesson here is very complex, and the trace minerals are very, very important. It's hard to really judge by deficiency symptoms, etc. Our best way is to try to get really good food and get the trace minerals. And this means we have to get food from a farmer or from somebody who really is oscillating their crops, making sure that their fields have the proper trace minerals. And one of the best ways is to try to get seaweed or algae into your diet. Very important, because that's the sea, has all these different trace minerals. Very important. We've made a science about each one of those, but it was too much to put into this video. This video is just about the base of it.
It's fascinating. Absolutely fascinating.
Yeah, so it's very important. We need to get these from and plants are going to be the best source of our trace minerals, of course. So, interesting.
So you sent one more. You sent, must I play the fourth one?
Okay, I'm going to call it quits here, and I'll let you play that one. And this is the video that talks about the Nobel Prize, my friend who won the Nobel Prize, and the work that we did. And this will really describe all the elements. And this tells about how he developed the process of discovering how the elements are made in the sun. And it's a comical little thing. It also would show the entire the periodic table. So it's kind of a fun little video. Okay?
Thanks for spoiling us.
Okay.
Okay, ciao. Bye, Rita. I'm gonna play the video now, guys.
Okay.
Thank you so much. Ciao, ciao. Bye.
We theorize that in the beginning of the universe, there was hydrogen and helium that got together and forged into stars. Inside the heat of the stars, this is where the other elements were developed. And this is basically the idea of the science, and my good friend William Fowler won the Nobel Prize for discovering this process. The theoretical and experimental studies of the nuclear reaction and the formation of the chemical elements of the universe. And he put together the ideas of this process.
All the atoms in the universe heavier than hydrogen and helium are forged by stars.
In the original universe, floating through space, there was hydrogen and helium. These two elements alone were to make up, later, stars.
Stars are the ultimate alchemists. They turn light elements into heavier ones. They get the energy that they need to glow that way. The star begins its life made out of hydrogen and helium mostly, about 70% hydrogen, 28% helium in the
The hydrogen and the helium floating in space will be drawn together by gravity until it gets large enough under the Goldilocks conditions to produce a high enough temperature to start into the process.
The star's core, the temperature and pressure are so high that hydrogen atoms fuse together to make helium. Hydrogen fusion releases prodigious amounts of energy, the heat and light of a star.
Massive temperatures that will start a type of fusion. A nuclear fusion producing incredible more heat and igniting the star. Then later,
the star runs out of hydrogen and begins to fuse its stocks of helium, making yet heavier elements.
the actual nuclei are then being able to be fused by the fusion reaction, where the combining of multiple heliums to make carbon can happen.
is taken 3 at a time to make carbon.
You can add 1 more helium to that carbon and make element number 8, oxygen.
That's a tremendous step forward. You get carbon and nitrogen and oxygen made in stars.
And now with the forces, all the other elements up to iron are capable of being made, as the nuclei are being forged together, fused, to make silicon, and all the other elements, nitrogen, phosphorus, etc., up to iron.
Now this is great because on the board we already have the principal elements of life.
Organic chemistry is the chemistry of carbon.
Carbon fuses next, and still heavier elements begin to form.
Sulfur, argon, chlorine,
potassium, calcium, scandium. The pace of this gets faster and faster.
Now the star will contract and expand and eventually get to a place where it explodes into a supernova. And now the incredible temperatures will create the rest of the elements of the periodic table.
In the middle, silicon is starting to burn at 3.5 billion degrees, stupendous temperature.
It makes titanium, vanadium, chromium,
manganese, cobalt, nickel, and iron.
This is the part of the process of William Fowler. Here he is winning the Nobel Prize in Sweden with the Queen of Sweden. And he came to Youngstown State University and met with me. He was born and raised around Ohio, Youngstown, in Lime, Ohio. He was born in Pittsburgh. And he came and we started to work together on an idea of transmutation in biology.
Iron is really the end of the road. It's sort of the nuclear turnip out of which you just cannot squeeze anymore.
Iron can't fuel this stellar furnace. And so, when a star builds up too much iron, it dies.
The other elements are now forged. We have the beginnings of a universe, planets, and all the forces.
Explosion can be as bright as 4 billion stars like the sun.
A stupendous explosion.
Such outrageous energies overcome the iron barrier, cooking atoms into all the rest of the elements on the periodic table.
Now, William Fowler spotted a mathematical process based on the laws of mathematics that allowed these atoms to be built. And later we could use this mathematical formula to find out about the trace minerals in the human body.
So starting down here, you can go copper,
zinc,
gallium,
germanium,
arsenic,
zirconium, niobium, molybdenum, technetium, rhodium,
ytterbium,
tellurium, iodine, xenon, cesium, barium, lanthanum, cerium, actinium, thorium, protactinium, uranium. Done.
All of this based on a mathematical process, needing the right pressure, the right temperature, all based on the science and mathematics that are laid down as the mathematics of life. And later, Dr. Isaacs and I will incorporate it into biology.
We are all stardust. The carbon in our bodies, the iron in our blood, the calcium in our bones. Every last atom was formed in a star.
All of the elements of the periodic table all come together and made kind of a nice little song.
What's the universe made of? I am so glad you asked.
There's antimony, arsenic, aluminum, selenium, and hydrogen, oxygen, nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, urethrium, uranium.
And nickel, neodymium, neptunium, germanium. Everybody! And
zirconium, lutetium, vanadium, anthium, osmium, astatine, and radium, and golden, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, terbium, actinium, rubidium, and boron, gadolinium, niobium, and iridium, and strontium.
There's yttrium, terbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium.
iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium. Just the Asians. And lanthanum and osmium.
Cadmium, potassium, chromium, mercurium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, arseninium, nobelium, and argon, radon, neon, and argon. Hold on, quiet.
There's gold and californium and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, kryptonium, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
If you didn't get that, let's play it one more time so you can see it on the chart in the mathematics.
Antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, kryptonium, and radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. Thank you. You may be interested to know that there is an older, much earlier version of that song, which is due to Aristotle, and which goes like this. There's earth and air and fire and water.
The mathematics of this periodic table, the elements, how they were structured in their energetic way, would allow us to understand electron transport chains in biology and allow us to understand about biology and the trace minerals of biology. So as we see here from the 1983 Nobel Prize on the formation of elements, there's a mathematical principle. Now, a long time ago, way back in 1869, Russian man Mendeleev, just by observation, saw that there was atoms. Didn't know anything about atomic structure or anything about that, but he could propose an entire periodic table based on the relationship and the formation. He actually predicted atoms that we discovered later. It was amazing. So I worked with Dr. Isaacs with his book Complementarity in Biology and tried to find a way to predict this mathematical relationship beyond just atoms into biology. Worked with Albert St. Georgi, and he had the idea of the math principles of this electron transport chain. So it was amazing to be able to find a way that we could really intimately understand biology. Working at Youngstown State University, I started to put together the book, The Promorpheus. I started to understand metabolism, reproduction, and all of the little intricacies about how energy, mass, charge, momentum, heat, all these different things were going to be handled and exchanged through mathematical principles. And then to put it onto a matrix so we could start to understand how atoms could share electron transport and accomplish the different things. And Isaacs imposed this very complicated matrix that we started to develop. Here's the electron poisoning curve, so we could see how electrons could work. And vitamin C sits right in the middle of that. And we started to understand the different elements and how they were needed. So I published this in the Promorpheus in 1982. Now, of all the different scientists I worked with Chelier and William Fowler and St. Georgi and many, many others, we're able to start to understand more about biology. And Rutherford had discovered a transmutation of the elements, being able to make different elements. And Kervran had an idea of biological transmutation, and how biology was going to be transmutating the elements. And that he found that in eggs, if we take eggs fresh from the chicken and destroy them, there's a different quantity of the atoms if we let them gestate for a long period of time. So biology was doing this. Now, after winning the Nobel Prize, William Fowler came to came to Youngstown State University to do a lecture. And as he lectured, I asked him the question. I said, could it be that we could transmutate the elements in biology? And at first he said, no, no, no. Then he said, well, wait a minute. He said, there's a possibility that through slow neutron capture, we would be able to do this with certain elements. So it was actually fantastic. William Fowler and I worked together on a paper, and were able to show that there was a way that biology could transmutate the elements. Very exciting. Has never really been accepted by modern science and physics, but I think it should be. It should get another look. But using this idea of his matrix from the 1983 stellar formation of the elements, and using it with Isaac's matrix, we can start to see the similarities. And this came into a whole new idea of handling the minerals and handling the idea of the trace minerals. So I put this together in 1982, and then having produced it, people had read it, and I got nominated for the Nobel Prize for this work. I presented this work at the Nobel Prize Hospital in Stockholm, Sweden.
Well, there we have it. An absolute spoil. I'm not sure about all of you listening, but this was absolutely fundamentally amazing. And the way Professor Dubounet puts this together, you know, dealing with our electromagnetic body, the chemistry involved, the biology involved, and the alchemy involved, is absolutely fascinating. And I mean, there's no doubt she's a great of greats. And having worked with all those people, I just really, you know, we really do need to revere her in the place and position that she's in. And to have her come and give us these beautiful videos, I hope you all are keeping them, because they are just greats. They're absolute greats. And what we did today was just phenomenal. So I think I can go on saying the same thing, but it was just incredible. I don't know if any of you got any comments to make in the chat about this. But what I do want to say, this is what the IMUNE diploma is full of. It's absolutely full of the most dynamic information and knowledge. It's not a situation of just getting a certificate. You're absolutely transforming, transmutating, transcribing yourself into something different, having done that course, which obviously leads to the licensed diploma as well. So you all know by now, if you want to join the IMUNE course, you can go to my website, 365healthybychoice.com, and go to courses. And the one at the bottom is the IMUNE 100-hour diploma course, which you can click on that, and then you can click on the mentor as well, which you require, and then you go and join the IMFlix, where the whole syllabus is in front of you and more. You can have the doctorate in front of you as well, and you get going at your own pace, basically. And then when you finish that, you would then hand that all into your mentor and have discussions, and then you go about getting your license. So just listen up here as well. There's a test that goes with the license as well. It's a 100-question short essay, short paragraph test that goes with the license, because the licensing aspect and the educational aspect are two different departments. All right, so Daisy's explained this to me. So just that you all know, the license is 150 euros, and there's an exam, 100-question essay test, whatever, that has to be done. Okay, and this is how Daisy is now setting a standard for the licensed quantum therapist diploma graduates, and really setting quantum therapists. We're putting quantum therapists into different places. So a true quantum therapist will have the diploma and will have the license. You know, the rest would be basically people who are training and technicians in a sense. So there's a massive professional opportunity here for everybody to really, really become not only medically secure, but legally secure as well. And then really taking this knowledge to the next level. So I really do urge you all to go and have a look on my website. You can go and you can pay from there. It's easy. And then join the IMFlix. It's about $15 a month. And just expand your space into the infinite infinity, which Daisy speaks about. So with all this nutrition, go and enjoy the rest of your day. Go and have your seaweed and go and have all your beautiful, your veggies and your plant-based proteins and long-chain sugars and minerals, vitamins, phytonutrients, etc. Breathe well. Drink your water. Get in the sun. Get on the ground barefoot and in nature, and really just absorb as many of these positive nutrients that you can. And well, who knows? A couple of us might end up being on the breatharian list as well. So open invitation. With that, if there aren't any chats, I think we can move on from now, and same time next week. So I think you're all getting it. It's every Wednesday at 7. And just be aware, I'm not always made aware of the topic. So I'm just going to be posting nutrition. All right. And then we see what the topic is as Daisy formulates it. And then Thursday, we've got Jane Live, which we do live cases with the quantum device and food state quantum nutrients. And then this week we have the Turning Point, which is our global cleansing and transformation event. And we've got an astrologer. We've got a sister Sister Dipti, who does our meditations, Dr. Reddy, biological dentist, and myself. And we lead that part of things as we've always done. And we're doing that because we've come to the end of the astrological Piscean age, and we are moving into officially, astrologically, the age of Aquarius. And we'll also be talking a little bit about the sun moon, which is in Aries. Okay, I think I got all those Aquariuses and Aries and everything right. So I'm going to be downloading this, putting it on the YouTube, Jane McKenzie YouTube. And this one I'm definitely going to file this one in a special place. It was magnificent. Thank you all for joining. It was an honor to be with you. And see you tomorrow, 7 p.m. South African time. All the best. Ciao.